Hey folks, welcome in this tutorial. This is Saurabh, and in this section of tutorial we are going to learn about math module in Python. So math module is a standard module in Python. Also it is defined as the most famous mathematical function which includes trigonometric function, representation function, logarithmic function and etc. Furthermore, it also defines two mathematical constants, that is pi and Euler number, and there are many more. So to use mathematical function under this module, we have to use import math module, so that we'll be able to use this module during our practical session. So it gives access to underlying C library function. So for example, suppose if you want to calculate a square root, then we have to import math dot square root of that number. Also this module doesn't support complex data type. It means we can't use a imaginary part within this module. And there are different math modules which I am going to show you in this session. So I will show you some of here. So Python module, some methods of math modules are math.pow, xy, floor, cell, ffs, modfs, log10. So I am going to explain all about thing with examples. So let's start with our first method, that is math.power. So we'll open our very important editor, that is PyCharm. So let's start with importing math module and doing some methods of math module. So first import math modules by import math, and I will import math as m. So you can change it as you want, but I want to use it as m. So here I have import math as m. Now I am going to see first method, that is math dot pow with x comma y. Now how will we able to use this? So this method returns the power of x corresponding to the value of y. If value of x is negative or y is negative integer value, then it raises a value error. So I will show you that how to use this during practical. Control Z, and now we'll start with our program. So I have already imported math as m. Now I will give number num is equal to, where I will use this math.pow, and here we'll write the the power of x, means here we'll put some values, and here I will put a value which will goes to the power of 4. Now we'll print this num, and we'll see that what happens to this. So now, so here we are getting 16 as our answer. So here I have written a variable that name is num, and that variable contains the math module with name m dot. I have used power methods, and here we have given two arguments. The first argument will be a number of which we want to know power, and second number will be power of that for a first argument, you can say. So here we are able to successfully we have done this method. Now let's go to the second method, that is math dot floor x. So here this method returns the floor value of the x. It returns the less than or equal to the value of this x. So I will show you that how to use this. Suppose we have given a new variable, and by using m I will going to use FL floor, and here we'll write some values in points. Now we'll print this n1 and we'll see that what will happen here. So this is giving 4 as the answer for this methods. I will remove this so that it will not create any problem for all of you. So here we are getting 4 only, but we have written here 4.5667. Why? Because this returns the floor value of x. So here we are seeing that the floor value means the less value for this number is 4. So we have to write a lowest number for floor. Now let's go to the third one, and here this is math dot something coin cell. So what is this method means? So here this method returns the cell value of the x, means high value of the x. It returns the greater than or equal to this value. Now I will show you that how to use this. N2 is equal to m dot cell, and here I will write 3.567. now we'll print this value with n2 and run this. So here we are again getting 4. Why 4? Because it will round up with 3.5 and it will see that whether this value is increasing more than 3 or not, because it is a ceiling function. So suppose if we are writing 3.4, so again we are getting 4. So it will completely make it a whole natural number by putting it towards its larger number. So here 3.4 means it will goes towards the 4. Here 4.5 means it will goes towards his less. So this was about floor function and ceiling function. Now we'll remove this and we'll go to our next function, that is math dot f apps of x. So this method returns the absolute value of x. I will show you that what is means of absolute. Suppose we have input sub number f apps as -345. Now we'll print this number n1 and run this. So now here we are seeing that it is printing 345 and here we have written -345. So it will make it absolute, means a positive number, if we have written it a negative. So the absolute method used in math module to make a number positive. So this is means of absolute in math module. Now let's go towards our another math module method, that is math dot factorial. It is very easy, everyone can understand that what is factorial means. So let's write the method for factorial, and here we'll put the number of which we want to know the factorial and print the variable 2. We'll remove this, and now here we are seeing that the factorial is 120, and it is correct because we know that the factorial of 5 is 120. After that we'll go towards another method, that is math dot mod f x. So here this method returns the fractional and integer parts of x. Suppose we have written something like 1.23, so it will divide this fractional part into 1 and 0.23. So it carries a sign of this x. So what will be the sign of this x? It will return that sign. So now let's do this. Suppose we have done m dot mod f, and here we'll put some fractional value. Now we'll print this n1 and we'll see that what will happen. So here we are saying that this is dividing this number into two part, that is 0.45, which is a fractional part, and 3, which is our number, which is without a decimal number. So also we have done a lots of math module method. Now let's see two more math module, that is log and log 10. So the method math dot log. So this method returns the natural logarithm of a given number. It is calculated to the base e. So suppose if we want to know the logarithmic natural logarithm of any number, so we'll use this function. I will show you that how to use this. n1 is equal to m dot log. Here we'll write some number. Now it's depend on us that what we want to put here. Suppose if we want to put 4, now we'll print this n1, and here we'll see that we are getting this number 1.3862. so this is a logarithmic with base e. And now if we use math dot log 10, then what will happen? I will show you this also. n2 is equal to m dot log 10 x, not x, I will put 4, and here will print n2, and now run this. So here this is a two different logarithmic function, that is log and log 10, and both have different answer because it has a base e and it has a base 10. So this was all about math module methods, and there are lots of many math module method which I am not going to tell you in this tutorial because it will make it very long. So I don't want to make this video very long. It is already long. So Python provides the several math modules which can perform complex tasks in a single line of code. So in this tutorial we have discussed a few important math modules. I hope that you all guys are able to understand this and just go and practice all these methods again and again, so you will become a sharp programmer. So this is the end of this tutorial. Thank you for watching. Don't forget to subscribe.